prompt. The fundamental theorem of calculus, which you have learned, particle motion, and average value. So we're just going to take the fundamental theorem of calculus, we're going to blend it into some particle motion and see what we can do. 3 things to keep in mind. Now you notice I drew 2 little graphs over there, so you're going to do the same thing. Now I want you to take a look. Yeah, snap. Look right here. When you integrate velocity, you get total distance traveled. Well, I better say you get distance traveled. And I want you to think about something. If I have velocity, don't write this down. This is not the graph I wanted you to look at. If I have velocity in feet per second, and I have time in seconds, what happens if I multiply the velocity times the time? Well, I have feet per second times seconds. Well, don't go there. Just straight look at that. I get feet. When I integrate a rate, I get a total amount of something. Okay? So if I integrate whatever my velocity function is, I will get feet or miles, total feet or total miles or whatever. I just want you to understand why when you integrate a rate, you get some total amount, and it's because that happens right there. Now, let's look at what I highlighted. The integral from a to b of v of t dt is p of b minus p of a. You know that this is just the change in position, right? Where v of t represents velocity, p of t represents position. Now let's talk about number 2. The integral from a to b of v of t dt is net distance, okay? Now you need to remember, net distance, if I'm going from here to Walmart, a net distance is just from here to Walmart. If I realize before I left that I left my wallet at home, and I have to go home, and then I have to turn around, and then I go back to Walmart, that's total distance, right? So let's take a look at number 2, and I want you to just sketch a little picture over here. We're going to just make it where the part of the function between a and b is above the x-axis. Now take a look at this. The net distance the particle travels on the interval from a to b. If the velocity is always positive on that interval, meaning the graph of velocity is above the x-axis, then it also represents total distance. You know that, because we never had to change direction. Now let's talk about what if we had to change direction. Let's draw a picture down here. I'm going to draw kind of a similar picture. But what I'm going to do is I'm going to make A be here, and I'm going to let B be right here. Now, if I'm graphing velocity, and this is time, if I am graphing velocity, and I'm going from time A to time B, then notice what I'm finding is this and this. So the part above the x-axis, if velocity is positive, what's happening? Velocity is negative, what's happening? So we change direction, okay? total distance the particle travels, it's going to be determined. Now I want you to look at that. If I just add those two pieces up, I'm not going to get my total distance traveled, am I? Why not? Right, because one's negative and one's positive. So the way you deal with that is you think, get a color, let's just do this. When I'm doing absolute value, it takes this part that's below the x-axis, flips it above the x-axis, okay? And remember, that flip happens where the velocity does what? Changes sign, which means the particle changes direction. Good. So I want you to pay attention to one thing right here. The total distance the particle travels on the interval a to b, use absolute value. Now notice whether or not v of t is greater than 0. To be safe, and this is true, to be safe, always do absolute value when you're asked to find total distance if you're given velocity. If you're asked to find total distance, use absolute value. You don't know how to integrate absolute value by hand, but that's where you'll have your calculator, and you can put an absolute value into an integral. Let me talk to Landon over here, and I'll be right back. Here we go. Number 1. The velocity of a particle that is moving along the x-axis is given by this function. Whoops. This is a non-calculator active question. If the position of the particle is 72 at t equal 4, then what is the position when t equal 2? Now I want you to notice we are given a velocity function. If you integrate velocity, don't put the a to b. I'm going to change that. If you integrate velocity, what do you get? What do I get if I integrate this thing right here? So I get p of b minus p of a. What we've got to think is, what do we want to integrate from what to what? I know the position at t equal 4, so I know p of 4. I want to find p of 2. So what do you think you want to integrate from what to what? From 2 to 4. So I know that's going to be p of 4 minus p of 2. Now again, I know p of 4 is 72. I can integrate 3t squared plus 6. So what I've got here, this is the integral from 2 to 4 of 3t squared plus 6 dt. So let's integrate that. Let me spread that out just a little bit. What's the integral of 3t squared plus 6? T cubed plus 6t, good. And we're going to evaluate that from 2 to 4. What's p of 2? Okay, so that was A. where P of 2 is equal to 4. Now let's go down to B. What is the total distance the particle travels on the interval 0 to 7? If I want to find total distance from 0 to 7, then I'm going to integrate. Now I want you to take a look at this. Now I told you didn't know how to integrate an absolute value by hand, and you don't. So he was a little sneaky when he told you this, because he told you this was a non-calculator question, so how are you supposed to do that? I want to show you something. I want you to look at that equation, 3t squared plus 6. We can make a sketch of 3t squared plus 6. What's that thing look like? 3t squared plus 6. It's a parabola. Vertex is where? Opens. Up or down? So I know this thing looks like this. That's really bad, but I know it's a parabola, right? Now, I can't deal with that. That's not okay. Sorry. That is not okay. That is not okay. That's not a lot better, but they connect. Do you notice that this is always above the x-axis? So this is always going to be positive. So we can just flat out integrate. This is going to be the integral from 0 to 7 of 3t squared plus 6 dt. We don't need the absolute value because those y values are always positive anyway. What's 7 cubed? I don't know what 7 cubed is. 343? If this had been 3t squared minus 6, where the graph would have gone like this, and we're integrating from 0 to 7, so we're integrating, we'd be integrating this, and then all the way up to there. I would have to use an absolute value because some of this region is below the x-axis, which means you could not do it by hand. You would have to have the calculator. Good question. Okay, we're good? Next page. You're going to have to use the calculator on this one. No, it says this is a calculator active question. We're starting another one. The velocity of a particle that's moving along the x-axis. I'm just thinking about what you asked me, Chase. I may refer back to that in a little bit. So number 2, the velocity of a particle that's moving along the x-axis is given by this function. The position of the particle at t equal 1.5 is 2.551. What is the position when t is 3.5? I'm given velocity. I want to know something about position. What do I have to do? I got to integrate. From where to where? Of v of t dt equals p of 3.5 minus p of 1.5. Now, let me say something to you on the AP exam. This would obviously be a calculator active question. If it was on the free response part, you don't have to write that function right here. You can write the integral of v of t dt if v of t is given. You don't have to sit and write this whole thing out. You can just write this, and that's just fine, okay? How are you going to solve it? Well, you're going to go to your calculator and you're going to integrate this. Go. So P of 3.5 is what, 15.919 plus 2.551? What is that? 47. I just want you to stay in the habit, 3 decimal places. Sadly, one group of graders may be more picky than the next year's group of graders. So let's just stay consistent. Okay. Okay. Next one. What is the total distance that the object travels on the interval from 1 to 5? Total distance. Absolute value. So you're going to integrate from where? 1 to 5? Absolute value of v of t dt. Just run it on your calculator. That's just terrible writing. That's what I got. Here we go. Guys, let's go. The graph of the velocity measured in feet per second of a particle moving along the x-axis is pictured below. Again, this is a velocity graph. The position of the particle at t equal 8 is 12. As soon as I see that, I'm writing this. What is the position of the particle at t equal 3? How are we going to find it? Integrate from 3 to 8 of v of t dt. And that's going to give you the position at 8 minus the position at 3. But we know the position at 8, and we know that integral. You are not given equations, but if we integrate a function, how can we find its integral? By looking at the graph, the area under the curve. So from 3 to 8, from 3 to 8, we need, oh, that's trapezoid. And a triangle. Okay, let's find the area of this thing right here. Now, I will be honest with you, I hardly ever do a trapezoid. I'm going to do a rectangle and a triangle. A trapezoid's not a big deal, but I just do rectangles and triangles. What's that, 5? So 5 plus, yeah. And then this is a 2 by 5. This is a 2 by 2. So the area of the green, this piece right here has an area of 10. This piece right here has an area of 2, but it's negative because it's below the x-axis. So what's the area of the total green? 8. So you're going to have 8 equals P of 8, which is 12, minus P of 3. So P of 3 has to equal 4. Now, let's look. Do we have units we need to deal with? The position, the velocity is measured in feet per second, so what's the position? 4 feet. 4 feet. 4 foot. 4 feet. Question B. I'll just talk to the board. What is the acceleration when t is 5? How do I find acceleration from a graph of a velocity? This slope. What's the slope of that line segment? That is lit. What's the line segment? What's the slope of the line segment? 5, 1. Let me see here. Is that 0.42? Yeah. 4, 5? What am I saying? 4, 2. Is that point? No. I know. What are the coordinates of that point right there? 4, 5. Okay. So what is the slope between 4, 5 and 6, 0? y2 minus y1 over x2 minus x1?
Yeah.
Is that better?
No, not really.
Ah! Now let's try this again. 5 over negative 2, right? Okay. Well, I probably need to. So the acceleration at 5. Now, do we need units? Are we given enough units to write? Velocity was measured in feet per second, so feet per second per second. Negative 5/2 feet per second per second. If you write feet per second squared, that is completely fine. But what's a square second? I know they do. I know they do. It's their fault. Okay. What is the net distance the particle travels from 0 to 10? Net distance. Now, do you use absolute value on net distance? No. So I'm just flat out finding the area under that curve. And I'm going from 0 to 10. So that means, what, I need all of that and all of this, right? All right. You can either do that thing as a trapezoid or 2 triangles and a rectangle. I don't care. I'm going to pause this while I figure them out. I think I got it this time. So the area of this part is 20. This part, negative 4. So the net distance the particle travels is 16 what? Feet. Foots. What is the total distance the particle travels from 0 to 10? 24, because it would be 20 plus 4, because you'd have to flip this up over the x-axis. So 24 feet.
If we are doing that, like on like using, is it okay with this?
Sure, because as long as you've shown, yeah, that's not an issue. Okay. The table above shows values of the velocity in meters per second of a particle moving along the x-axis at selected values of time t seconds. What does the value of the integral from 0 to 18 of v of t dt represent? Net or total? Net. From time 0 to time 18, or you could say from 0 seconds to 18 seconds. Using a left Riemann sum. Stop it. Of 6 subintervals of equal length, estimate the value of the integral from 0 to 18 of v of t dt. Indicate units of measure. I need 6 subintervals. Well, your 6 subintervals, 1, 2, 3, 4, 5, 6. There are your 6 subintervals. Now it said 6 subintervals of equal width. Do all of those subintervals have a width of 3? Yep. We're doing a left Riemann sum. So here's how you're going to write it. The integral from 0 to 18 of v of t dt is approximately, and please use approximately, left Riemann sum. Can I pull out the width of each one of them because it's the same? Yep. Times. What's the height of the first one if I'm doing a left Riemann sum? Height of the second one? And I'm going until, what's my last entry going to be? 1.7, right? 1, 2, 3, 4, 5, 6. Look. 33 what? 33 meters? 33 meters. No, it's not meters per second. This is distance, so 33 meters. Okay. Using a right Riemann sum of 6 subintervals of equal length. Right Riemann sum. Do I need to change my subintervals? No, because I've got 6 of them. Which of the heights am I going to start with? 2.7 and end with 2.1. Good. And please put is approximately. Let me see here. 2.7. What are you getting? 30, yeah, 32.4 meters. Doing all right, Dylan? Okay. You good? 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 Okay. Option D. Using a midpoint Riemann sum of 3 subintervals of equal length. Midpoint. Midpoint. 3 subintervals of equal length. If I'm going to do a midpoint Riemann sum, how many of these little columns here am I going to have to use for one subinterval? Yeah, so 1, 3 of them, this one, and this one. Yeah. Midpoint Riemann sum. Integral from 0 to 18 of v of t dt is approximately. What's the width of each of those subintervals? 6, good. Times got the approximate already. Did you get that? 34.2 meters. We have a, sure want to get to it. I think I agree. We have a released AP question on the next page that I really want to get to, and that's our last thing. But please look at F. Let's do F. Find the average acceleration of the particle from t equal 3 to t equal 9. I need you to think about this for a minute. If I find average speed, what do I do? The change in the position divided by the change in time. So if I'm trying to find average velocity, change in position divided by change in time. So average acceleration would be change in velocity over time, right? So, average acceleration, 3 to 9, v of 9 minus v of 3 over 9 minus 3. Run that and let's see what you get. Negative 0.233 what? Meters per second. Now I want you to look at this last question here. For what value of t in the table is this average acceleration approximately equal to v prime of t? We found the average acceleration between 3 and 9. Here and here. We found the slope of the secant line between t equals 3 and t equals 9. That should estimate or approximate the instantaneous velocity at y. Okay, it's called the mean value theorem. Do you remember the mean value theorem? The mean value theorem says if a function is continuous and differentiable, then there exists a c, and I'm going to say on the open interval 3 to 9, such that v prime of c equals so it's approximately v prime of 6 because of the mean value theorem. Okay, let's go to this one. Now listen, if we don't finish this, I'll have to stop the recording, but after school I will record a short video to finish it because I don't want you having to do this one by yourself, okay? So on Classroom, it may have the long video here and then a short one that finishes up. All right. A car traveling on a straight road with velocity 55 feet per second at time 0. Snap, I don't want that. So I know that v of 0 is 55. I also know that this is acceleration. For t, from 0 to 18, the car's acceleration, a of t, is the piecewise linear function defined by the graph above. The first question should be easy for you. Is the velocity of the car increasing at t equal 2 seconds? Why or why not? Good. We know that the acceleration at t equal 2 is positive because the graph is above the x-axis at t equal 2. So when acceleration is positive, velocity is increasing. Good. So we'll say velocity is increasing at t equal 2 because let's do it this way, because v prime of 2, which is a of 2, is positive. It's the b part that I'm concerned about getting through. The b part. Got this? All right. Let's try that again. At what time in the interval 0 to 18, other than t equals 0, is the velocity of the car 55 feet per second? Oh, yeah, the answer is yes, but it's done very differently. But the answer to that is yes, I remember. Yes, we did. Because I think you had like from something to k, you had a k in a problem. Now, well, we'll go over that all on Tuesday. I will grade and grade and grade and grade and grade this week. Now, in a good way or a bad way? At what time other than t equals 0 is the velocity of the car 55 feet per second? We were told at time 0 that the velocity was 55 feet per second. Now, here's what I need you to think about. From time t equals 0 to time t equals 6, what do we know about the velocity of the car? Why is the velocity increasing there? So I know that the speed of the car is going up from time 0 to 6. You with me there? So I know at this point, I know the velocity is more than 55 feet per second. What happens down here? The velocity starts to decrease. So the question is, if we have been increasing from 55 feet per second, increasing, how far down do we have to go to get back to 55? Why 12? Say again?
You spent 6 seconds increasing your velocity, so you spend the other 6 seconds.
In this case, that works.
In this case, that works because, yes, because what you got to think is it's sped up that much, so it's got to go down that much, right? And it just so happens that this area is the same as that area. So you're going to say the velocity of the car is 55 seconds again at t equal 12. Why? We could say in words what you said, but we could also say something like this. At t equal 12 because what is the integral? Yeah. What's that integral? What's the big deal about the acceleration ending up being 0 over that interval? No change in velocity, right. So I know from 0 over that whole interval, 0 to 12, overall, there's no change in velocity. Does that help? So the other thing you could actually verbally or writing down in words that the area from 0 to 6 and the area under the curve from 6 to 12 are exactly the same, but one's above the x-axis and one's below the x-axis. So you know the car was speeding up until time 6, and then it had to slow back down to 55 at t equal 12. Yeah. Oh yeah, oh yeah, oh yeah.
So we just find it like where it all gets it up.
In this particular one, yes. Question.
We didn't get a graph on the coast.
You didn't need it. It was a different question. We'll talk about it Tuesday.